Welcome to Constructotech, the home of colossal machines that move Earth and shape the world. Times have changed, a lot, and so has the technology that powers bulldozers. Renowned for their capacity to haul mountains, sweep forests, and munch concrete at will, these mechanical Goliaths are such an intimidating figure on the construction site. But peel back the steel, and you'll find the brains behind the brawn, a collection of smart engineering tools and features that ensure every lift, push, and dig is a success. From satellite-guided GPS to climate control systems and mind-blowing powertrains, these are the unbelievable tech behind bulldozer construction. The undercarriage isn't just a tool, it's a combination of interconnected components, including tracks, sprockets, rollers, and idlers. So how exactly do they function? Well, tracks are durable steel that evenly distribute weight, minimize ground damage, and reduce the risk of sinking when the bulldozer operates on soft, muddy, and uneven terrain. Sprockets drive those tracks forward and in reverse with force and control. And while all that is happening, the rollers are there to bear the load, ensuring that everything is moving smoothly. And the idlers? They maintain perfect track tension, stopping derailments before they start. Together, these components work as a unit to deliver the stability and mobility bulldozers need to dominate rough ground, exactly when the operator demands it. However, the undercarriage isn't the only component the operator summons. In carving land, crushing debris, and doing all the heavy-duty stuff a bulldozer's meant to do, an operator would often deploy two other critical components. Blades and ripper shanks are essentially best buddies separated by the length of the bulldozer's frame. Located on the front end of the dozer, the blade is a giant slab of metal used for pushing, leveling, digging, and carrying materials on the site. Sounds straightforward, right? Not exactly. You see, the blade is responsible for some of the most punishing and mission-critical jobs a dozer is built to handle, and that's why it comes in four specialized forms. First up is the straight blade type, which is used to execute basic tasks like fine grading, backfilling, spreading, and pushing materials across short distances. Then there's the angle blade, pivot-friendly and perfect for tasks that demand surgical accuracy, like ditching, windrowing, or snow clearing. Next is the universal blade U-blade, the heavy hauler and the go-to option for pushing massive loads over long stretches. And finally, the semi-U blade, a hybrid tool with smaller wings and a subtle curve. It blends power and precision, making it ideal for tasks like crowning and ditching. But even the toughest blade has its limits, which is where ripper shanks step in. Mounted firmly on the back of the bulldozer, the ripper is a long claw with sharp-pointed tips. Its primary task is to rip through compact and hard surfaces, breaking them into smaller materials that can be moved by the blades. Depending on the mission, you'll see either a single shank ripper for maximum depth or a multi-shank setup to cover more ground in one go. Next on the list are advanced controls and automation, a set of fancy technologies that would make early 2000s luxury cars feel jealous. Unlike their predecessors, modern bulldozers are designed to move Earth. They do it with precision, efficiency, and high safety standards. Of course, to achieve this, you need much more than raw power, which is where GPS, real-time 3D mapping, laser-guided sensors, and other smart technologies come in. Think of the Komatsu D61 PXI, an intelligent dozer that can automatically lower or raise its blade while the operator steers the wheel. Some D-series dozers go even further with auto-carry capabilities and full integration with MindStar Command, enabling remote and semi-autonomous control. Essentially, what this means is that an operator can be in the US and remotely control a bulldozer in sub-Saharan Africa, live and in real time. Such astonishing capabilities are made possible by a combination of smart software and incredible engineering. In the D7, for instance, there's a signal unit on the left side that hooks the bulldozer directly to the command control center. Up top is a status light that shows whether that remote connection is active or not. And of course, there are cameras all around the dozer to give the remote operator a bird's-eye view of the situation on the ground. On the other side, there's a control box that holds the keys to all the magic. Flick the switch on and the light is immediately activated. At first, it boots through different colors, but once it settles on blue, it means this bad boy's now ready to be remotely controlled. A few decades ago, that would have been termed as sorcery, but today it's just another day of remote working. And it's all thanks to the relentless innovation of inventors who fused brainpower with brute force to reimagine what bulldozers can do. We're already far gone into the list. Trust me, we've only scratched the surface. There are still plenty more bulldozing technologies coming your way. But before we leap forward, let's hit reverse for a minute and see how these steel beasts were born in the first place. The history of bulldozers is a hotly contested topic shrouded in mystery. Some say they were invented by Benjamin Holt in 1904, while others claim the machines have been in existence long before the American businessman and inventor introduced his version. It's hard to know who's telling the truth, but here's what we know. Early bulldozers looked nothing like the gigantic crawlers dominating today's construction sites. The earliest form of bulldozer was basically strong wooden boards attached to the tines of pitchforks. Yeah, I know it sounds awkward, but our ancestors thought it was useful until they realized it wasn't. So, as the years went by, they upgraded to wooden blades strapped to mules or horses. Believe it or not, that was a major upgrade, saving time and taking the edge off backbreaking labor for farmers and early builders. But as the world grew, so did its challenges, and those homemade rigs just couldn't keep up with the industrial demands of large-scale construction and land clearing. That's when visionaries like Holt stepped in and ramped up the development of futuristic bulldozers. By the early 1920s, the world's first mechanical dozer had been invented. From there, it was full throttle. Engineers pushed forward, refining every inch of the machine. Powertrains got stronger, transmissions got smarter, and what started as wooden boards on animal backs evolved into tech-loaded monsters capable of reshaping the planet. Those two are the heart and soul of bulldozers because they generate and supply the energy required for the machines to push, pull, and complete all its heavy-duty tasks while maneuvering through different environments. Traditionally, most bulldozers are powered by diesel engines capable of handling high-demand construction tasks and maintaining consistent performance through tough conditions. But times are changing. Today, you'll find bulldozers powered entirely by batteries and electric motors. Cleaner, quieter, and surprisingly capable. And right in the middle, you've got hybrid bulldozers that blend diesel power with electricity to boost both performance and efficiency. Currently, though, many of the world's biggest and most powerful dozers still rely on traditional diesel engines. That includes the ACCO Super Dozer, which is powered by 2 HP Caterpillar engines and generates a total of 1,350 horsepower. And right next to it is the Komatsu D575A3, which boasts 1,150 horsepower and has the capacity to lift enough dirt to fill 6 dump trucks at once. But all that horsepower means nothing without the transmission. In simple terms, the transmission's a system of gears that sends powers from the engine to the undercarriage and other components. And like dozer blades, they come in different types. First, there's the hydrostatic transmission, which uses hydraulic fuel to fine-tune speed and direction, offering surgical control in tight spots. Then there's the power shift transmission, a gear-driven setup that lets the operator shift on the fly, throwing torque exactly where it's needed. Back when mechanical bulldozers were first invented, the operator's cab was just another metal box with few levers, just enough space to get the job done. In contrast, modern cabs are essentially high-tech command centers built for performance and comfort. Inside, operators are surrounded by ergonomic controls, touchscreen displays, fully adjustable air suspension seats, and climate control systems that keep the temperature just right, no matter the weather outside. But comfort isn't the only upgrade. These advanced cabs deliver real-time performance data, system diagnostics, and precision settings that let operators fine-tune the machine like never before. And let's not forget the unsung heroes outside the cab like the hydraulic pump, which builds pressure and sends fluid surging through the hoses. Valves that control movement across every attachment. Electrical system to power everything from lights and sensors to switches and touchscreen interfaces. And of course, the cooling system that keeps the engine from melting, even in extreme conditions. While the technologies we've covered today are more than capable of handling the toughest construction challenges of our time, they're definitely not the final word. As our civilization continues to evolve, we could be looking at a future where bulldozers operate with full autonomy, executing complex tasks without a single human in the cab. And who knows, swarm bulldozing, where fleets of robotic bulldozers work together like a construction hive, might not be science fiction for much longer. If that excites you, make sure to hit the like and subscribe button, and don't forget to check out our channel for other interesting videos like this one.